Welcome back. In today's class, we will see how to use dictionaries and sets in our Python programs. Dictionaries and sets are both unordered data structures. Previously, we looked at lists and tuples, both of which were ordered data structures. So suppose we don't care the order in which items are stored within our data structure, we can use either a dictionary or a set to store such data. First, let's see how to create a dictionary, what kind of objects can be stored within a dictionary, and then we will look at sets and what's the difference between a dictionary and a set. Now, to create an empty dictionary, the syntax is as follows. Empty underscore dict is the name of the variable, and we are assigning it a pair of braces. Since there is no item inside the pair of braces, it creates an empty dictionary object. Now, a dictionary in Python, a dictionary is implemented as a class in Python. So when we call the function type and pass empty underscore dict, it returns the type to be class. The name of the class is dict. So first let's look at the print. Okay, now there is a lot of similarity between lists and dictionaries. In the previous class we looked at lists. Lists were useful to store items of different types, and we could simply use an integer index to access a specific item or a value. Now first let's look at how to create a phone book in a Python program using lists. Now the phone book should have names, and each name should have a phone number associated with it. To create a phone book using lists in Python, we need to store names in one list and the corresponding phone numbers in the second list. Since lists are ordered, we should also pay attention to the order in which the names are added to the first list, and we should add the numbers to the second list in the same order. We can then use the zip to iterate through multiple lists. We saw this in the previous class. So for k, v in zip phone underscore book underscore names, phone underscore book underscore numbers will simply iterate through both these lists simultaneously, and it will print the items or elements stored within these individual lists. Okay, so when I print all the items in these two lists, we should see John's number is 123, Jane's number is 234, and Jared's number is 345. Okay, so we created a phone book by using two lists. The first list was a list of names, the second list was a list of numbers. Now there is a more simpler way of doing this in Python, that's by using a dictionary. Dictionary is more suitable when we have a natural key order pair in our data. We can create these key order pairs and store them as items within our dictionary. So to create this phone book as a dictionary, the syntax is as follows. Phone underscore book is the name of the variable. On the right hand side, we create a pair of braces. Within the pair of braces, we will create key value pairs. So the syntax to create key value pairs is as follows. First, we will write a key. Key here is a string. And then we will follow it with the colon, and after that a value here is an integer. We can create multiple key value pairs and add it to the dictionary. We will simply use comma to separate key value pairs. So key here is a string, so John, Jane, and Jared are the keys. Value is an integer, 1, 2, 3, 2, 3, 4, 3, 4, 5 are the values associated with the keys. Now notice both keys and values are stored in the same data structure, so we don't need to really worry about the ordering of keys and values like with lists. And we can simply print phone underscore book. This should print all the items or the elements of this list dictionary. Now dictionary is versatile, and first let's see what kind of keys can be created. It's not necessary that keys are always strings. Key can also be an integer. So I can create 1 and store a as the value, the character a. I can create the second key as 2, store another character as the value. And I can also use tuples to be keys. So a key can be any immutable type in Python. And the immutable types that we've seen so far are integers, strings, and tuples. So I can create a tuple of values, so it can be anything. And as we saw in the last class, tuples are immutable. That is, once we add elements to a tuple and create it, we cannot add more elements. And now the value can be a list. So it's not necessary the value should be a string or an integer. It can also be a list, it can be a set, it can be a tuple, it can be even a user-defined object. So this is a valid syntax in Python. There is a syntax error here because I forgot to write this within a pair of braces. Okay, so now when I print A, this should print all the key value pairs stored within this dictionary object. So a dictionary is really powerful, as I mentioned before. The keys can be any immutable types, value can be any type in Python. It can be an integer, it can be a float, string, lists, sets, tuples, or even user-defined objects. Now let's look at what happens when we pass dictionary to some inbuilt methods. First, let's see what happens when we pass a dictionary object to len. Previously, we saw when we pass a list to len, it simply returns the number of items in the list. Now the behavior should be similar with dictionaries. It should simply return the number of key value pairs in the dictionary. Since our phone_book had 3 key value pairs, the number of items in our phone book is 3. Okay, now suppose I want to delete a particular key value pair, we can use the del keyword. So del phone_book in square brackets John will delete the key John and its associated value. So now when I print the phone book again, we should see only 2 key value pairs, chain and Jared. Now suppose I want to delete all the key value pairs, I can use the clear method. So clear is again an inbuilt method in this class TICT. So since phone_book is an object or an instance of the class TICT, I can call it its methods using the dot operator. So now dot clear will simply delete everything. So we should see an empty dictionary at the end. Now let's look at more examples. Here I want to show you first how to access a certain value using a key. To access a value using a key, we will use the square brackets operator. With lists, we were writing an integer index within the square brackets operator to access the corresponding item or value stored within the list. Now with dictionary, we can instead use a key within the square brackets. So here I'm creating a new dictionary, prices. The keys are espresso, americano, latte, and pastry. And its corresponding values are 5, 8, 10, and various prices. Now suppose I want to know what's the cost of latte. I can simply access the value associated with latte using the square brackets operator. Since it's an integer, I'm converting it to a string and then concatenating it with $ using the plus operator. So now let's look at what will be the cost of latte. So this should be $10. Okay, so similarly, we can also query what's the list of pastry, and this should give us various prices. Now, it's not necessary that, so first, now let's check what happens when we pass a non-existent key to the square brackets operator. So here I'm printing the price of Irish coffee, which does not exist in our prices dictionary. So the syntax here should already give away what happens. There should be an exception raised. So since I'm writing this in a try except block, this particular piece of code will cause an exception. The reason for exception is because of a non-existent key. We are trying to access this particular dictionary using a key that does not exist. So this should cause an exception. And we are handling this exception by using a try except block. So now Irish coffee does not exist should be shown on the terminal. So what this shows us is that when we are using square brackets operator to access a particular key value pair, we should make sure that either the key value pair is already added to our dictionary object, or we should write this particular statement within a try except block and handle the exception when the key does not exist. Now a more safer way of doing this is by using the inbuilt method get. We can simply pass a key to this method get, and get will simply return the value associated with this key. And notice here we can also pass an invalid or non-existent key, and Python will simply return none when the key does not exist. So when I print prices.get Irish coffee, the return value is none since Irish coffee does not exist. Okay. Next, let's see what happens when we write this line. So here we already saw that Irish space coffee does not exist in our dictionary. So when we try to access it with square brackets operator, it caused an exception. However, this line should execute when we try to assign a value to this key which does not exist. Now what Python does is when it executes this line, it first checks whether Irish space coffee is a valid key. If it's a valid key, it simply modifies the value. If it's not a valid key, it'll create a new key value pair. So the key now is Irish space coffee and the value is 10. So the next line simply shows you what happens when an existing key is modified. Americano is already part of our prices dictionary. So when I write this statement, the current value, which is 8.0, corresponding to this key Americano, should be modified and the new value will be 8.5. So now when we print the prices dictionary after updating it, notice there is an additional key value pair, Irish coffee and its corresponding value, and Americano's price is now changed from 8.0 to 8.5. Okay. We can also use the update method instead of using the square brackets operator and the equal to statement to assign a new value. We can use the update method. We can pass a key and then assign it a new value. Now notice the key here is not with a single quote, or it's not using quotes. So even though Americano was a string, we are simply passing Americano as an argument and assigning it a value equal to 12.5 when we call the update method. So this should change Americano's price from 8.5 to 12.5. So we can either use the square brackets operator and access a particular key value pair and modify its value by assigning it a new value, or we can use the update method. Now let's see how to remove an item from our dictionary. Suppose I want to remove Americano and its corresponding value. I can simply use the inbuilt method pop. So prices.pop Americano will remove Americano from our dictionary, and it will return the value associated with this particular key. Now previously we saw how to use the del keyword to delete a key value pair. The del keyword does not return the value associated, but it removes the key value pair from our dictionary. Now when we use the pop also removes the key value pair from the dictionary, but it returns the value back. We can use the value to print what Americano costs. We know that it's $12.5, so the return value is 12.5. Now we also need to be careful when we are using the pop method. If we pass an argument or a key which does not exist, this function will cause an exception. It will throw an exception, and the exception is of type key error. So let's run the program again. And notice now we got a runtime exception. The runtime exception says that there was a key error since we were trying to pop a key that does not exist within our dictionary. So in order to handle this, we can again use the try except method. We can put this particular line in a try except method and handle the exception in the except block. Or we can simply pass an additional argument to this function call, which will be the default value that is used when the key does not exist. So suppose latte exists, it returns the value associated with latte. If it does not exist, it simply returns none. Okay, so now let's run the program again and check what's the value when we pop latte with capital L. Now notice, since latte with capital L is not part of our dictionary, it simply returns none. And when we try to pop latte this time with the correct case, it should remove latte and it should print the corresponding value, which is equal to 10. So the second parameter is used only when the key does not exist. If the key exists, the value returned is the corresponding value. And also, now we can see that prices will have one element less. So it only has 3 key value pairs, and that is not part of it. Okay, now let's look at what happens when we call the pop item method. So suppose we are not interested in removing a specific element, we simply want to remove the last element, we can use the pop item method. So when we call pop item on prices dictionary object, the return value now is a tuple, which is the key value pair. Previously we were passing a key to the pop method and it was returning a value. This time, since we are not passing any thing to this pop item method, it returns us both key and the value. So now when I print val, we should see Irish coffee and its corresponding value, which is $10. Okay, now let's look at how to create nested dictionaries. So a nested dictionary means that the value of the dictionary of a key is also a dictionary. So here I'm creating digits. The keys are integers 1, 2, 3, 4, 5, and the corresponding values are all dictionaries. The second dictionary has 2 keys. The first key is word and its value is a string. Second key is again Roman. Its value is again a string. Now suppose I want to access a particular key value pair in this nested dictionary. Let's see how to do that. So I want to know what is 1 in Roman. To do that, first I can use the square brackets operator with the first key. The first key is an integer, so I can use one of the 5 integers. Since I want to know what is 1 in Roman, the first key is 1. This will return as the value, which is a dictionary. So I can again use the square brackets operator, this time with the corresponding key, to get its value. Since I want to know what is 1 in Roman, the second key is Roman. So now when we print both the dictionary digits and the second 1 in Roman, we should see the corresponding prints. Okay. Next, let's see what happens when we construct a new list by passing a dictionary as an argument. So here I'm creating a variable called keys, and it's assigned with a value, which is, I'm creating a new list by using lists and within parentheses and passing a dictionary object. Now what this does is should be evident by the name of the variable. This will simply return the keys that are part of our dictionary in a new list. So keys is now a list of keys within our dictionary digits. Since 1, 2, 3, 4, 5 were the keys of our dictionary digit, keys is now a list which contains elements 1, 2, 3, 4, 5. Now, once we create this list of keys, suppose we modify our original dictionary, this list of keys will not be changed. So to see that, first let's pop an item from our digits dictionary. This will remove the last key value pair, and then let's simply print the data structure keys or the value keys, and let's look at the values. Now notice keys before popping is 1, 2, 3, 4, 5. Keys after popping is also 1, 2, 3, 4, 5. So once we create a new list of keys using this syntax, even if we modify the original dictionary, we will not see the changes in the keyword in the variable that where we have stored the keys. Suppose we want this variable to change whenever we change or modify the dictionary, then we need to use the following syntax. So here I'm creating again 2 variables, keys and values. Keys here is now the written value of this function called dot keys. So digits is a dictionary object, and I'm calling an inbuilt method keys. This will return as a view of the keys. We will not worry about what view is. For now, let's simply look at the print statements. Similarly, I can use an inbuilt method values. This will return as a view of the values. And we can simply use keys and values in our print statement, and this should print the keys and the values. Notice keys has 1, 2, 3, 4, 1, 2, 3, 4 as its elements, and values as corresponding values. Now, the type of this variable keys is dict underscore keys. The type of this variable values is dict underscore values. We will not worry about what these types are. All I want you to remember is these types are iterable types in Python, so we can simply use these types to iterate in a loop. We can also convert them into lists by passing them as an argument to the list constructor. The more important point that we should see with this particular syntax is, now suppose I remove an item from our dictionary digits. Let's see whether removing this item will change the keys and the values variable. So now let's print keys after pop item. Now notice before pop item it was 1, 2, 3, 4. Now after pop item it has only 3 keys, 1, 2, 3. So removing an item from the dictionary updates the keys and the values, since we use the inbuilt method .keys and .values. Now the view is simply saying that we are getting a view of the keys of our original dictionary. If we modify the original dictionary, the view also changes. Okay. Next, let's look at what happens when we use equal to copy a dictionary. With lists, we saw that this does not do, this will not copy lists. This is simply, digits 1 is simply an alias to digit. So the behavior is again the same with dictionary. So digits 1 is an alias to digits, it's not a copy. Suppose I remove an item from digits 1, it also removes the item from digits. So I'm printing digits before pop item. So let's look at digits. Notice digits has 3 key value pairs. Now I'm removing one key value pair using the pop item method. And now when I print digits back, notice again digits has only 2 key value pairs now. Even though we used the pop item method on digits 1 object, it also affected the digits object. So digits 1 is simply an alias. If we actually want a copy, we need to instead use the method copy. This creates a new copy of this dictionary and stores it within digits 1. So now when we execute this line and print digits before and after the pop item, we should see that digits should remain the same. So it has 2 key value pairs before pop item, and after pop item it still has 2 key value pairs. However, digits 1 should have only 1 key value pair, since we removed one item using pop item. So simply writing A is equal to B when A and B are both dictionaries, it creates an alias. If we want a copy, we need to use the inbuilt method copy. Now the in operator and the not in operator also works with dictionaries. We can simply use the in operator to check whether a key is part of the dictionary or not. And similarly, not in to check whether the key is not in the dictionary. Since 1 is in the dictionary, this should return a true. Since 100 is not a valid key in digits, it should return again a true. Okay. Next, let's see how to iterate over keys. So there are 2 ways we can iterate over keys. The first way is we can simply write for obj in my underscore dict. My underscore dict is now a new dictionary. Keys are A, B, C, values are 1, 2, 3. Now we saw the syntax again with lists. With lists, obj will be an element within the list. Now with dictionary, this will be the key instead of the value. So when we print in this for loop obj, we should simply see the keys A, B, C. We can also use the keys method. Since it returns as an iterable, we can simply use for key in my underscore dict.keys. This is again a valid syntax, and we can simply print all the keys. This should again print ABC. And we can again use dot values, since dot values returns as an IEEE object, which is of type dict underscore values. We can simply use that in the for loop and print all the values. Okay, now this time it prints 1, 2, 3. Now we can also use the inbuilt method items, and this time it will return us a key value pair, which is a tuple. So let's look at the syntax first. So syntax is for obj in my item, my underscore dict dot items. So items is an inbuilt method within this class dictionary. This returns as a tuple of key value pairs. So obj is of type tuple, and the first element of obj is the key, second element is the value. So now when I run this for loop, we should see the 3 tuples a, b, a1, b2, c3, and each of them are of type tuple. Okay, we can also use the unpacking of tuples. So here I'm unpacking the return value of this items method to 2 different variables, k, v. K will be the first element of the tuple, which is the key. V will be the second element of the tuple, which is the value. So now when we print this, we should simply again see the key value pairs. Just A1, B2, and C3. So these are some different ways of iterating through a dictionary. And finally, I want to show you an example of how to do comprehension with dictionaries. Previously, we saw comprehension works with lists. Now we will see that it also works with dictionaries. So here I'm creating a new dictionary, squares, and let's look at what is the content of this dictionary. Okay, now notice the content of the dictionary. Each key is now just simply x. So square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16. So each key is x and each value is x square. So it's again key colon value, and then we are writing the for to loop through x within range 0 to 10, and instead of writing this within square brackets, we're writing this within a pair of braces. So this creates a dictionary instead of a list. So this ends the topic on dictionary. Now let's continue with sets. A set is an unordered collection of items with no duplicates. So first let's look at how to create a new set, and then we will see how to use some inbuilt methods to do mathematical operations like union, intersection, and difference. To create a new set, we can either use a pair of curly braces or the set function. So suppose we want to use the pair of curly braces. The syntax is as follows. I want to create a basket of fruits. So basket is the name of the variable. On the right hand side, I'm assigning some strings as the value that I want to store in this list, which is separated by commas, and I'm writing those strings within a pair of curly braces. Now notice, even though there are duplicates on the right hand side, Python will remove these duplicates before creating the set. So when I print this basket, we should see the contents of the basket is apple, orange, pear, and banana. Since sets are unordered, the order in which we assign the elements is not the same as the order in which they are stored. The order can be different. Now we can use the in function, in operator, to check whether an item is part of the set or not. Here I want to check whether orange is in the basket. So I can use orange in basket expression to check whether orange is in basket. Since we know it is in basket, the return value is true. If the orange was not part of our basket, the return value would have been false. Now to create an empty set, we cannot use the curly braces. The reason why it is clear. We know that when we write this following statement, Python will create a dictionary instead of a set. Both dictionaries and sets are created using a pair of curly braces. The difference is dictionary has key value pairs as elements. Sets only have values or items. Both are separated again by comma. Now let's look at the type of this variable empty underscore set and the type of this variable empty underscore dictionary. We know empty underscore dict is of type class. The name of the class is dict, Now empty underscore set is also of type class, and the name of the class is set. So sets are again implemented as classes in Python. So we can use some inbuilt methods to do operations on sets. First, let's look at what happens when we construct a new set by passing a string as an argument. Here I'm creating a new set using the set function by passing a string hello. And the return value is stored within this variable letters. So what Python does is when we create a new set by passing a string, it will simply return the set of letters that are part of the string. Now notice again it removes duplicates. Since there are two L's in hello, it only returns 4 characters, H, E, L, and O. So if you want all the characters within a string and you don't want duplicates, you can simply pass the string to set, and set returns the set of characters or letters. We can again use the len function by passing a set to query the number of items or elements within the set. They should simply return 4. Now we can also pass this string hello to a list. And what Python does is this time return as a list of characters. And now since lists support duplicates, we also get both the else, and since lists are ordered, the order of these characters is the same order in which they are in the string. So if you want to convert a string to individual characters, and if you want to maintain order and also store duplicates, use list, otherwise use a set. Okay, now we can use the equal to operator to check whether two sets are equal. Sets are again unordered collections of items with no duplicate elements, so we can simply use the equal to operator to check whether two sets are equal. Now notice here set 1 is A, B, C, set 2 is B, C, A. The order is different, but the elements are the same. So therefore, we should get that set 1 is equal to set 2. If these two were lists instead of sets, then the equal to operator would have returned a false. Okay, now let's look at some inbuilt methods. The first inbuilt method is add. We can use the add method to add more items or elements to the set. Here my set is some numbers 1, 2, 3, and now I'm adding 5. So now after adding 5, the set should be 1, 2, 3, 5. Okay, so the dot add is the method, inbuilt method. So we can simply use the dot operator to call inbuilt methods. So nums dot add will add 5 to the set nums. Similarly, we can add a string. Now let's see what happens when we add string, and then let's print it. Now notice Python does not convert this string to a set of characters. Only when we pass a string to the set function, it creates a set of characters, and it creates a new set, a set of characters. When we pass a string to the add method, it simply adds the string as an element to our set. So the new element is hello. Similarly, we can use the remove method to remove an element. So I'm removing 2 from the set, and now we should have 1, 3, 5 hello. We can also use the inbuilt method discard to discard an element. So nums.discard 1 should simply remove 1. So both remove and discard works the same way. It removes an element. We can also use the pop method to simply remove an element. And now let's check what is the nums. Now notice pop removes the first element from our set. So here it removed element 3. There is no pop item in sets. Pop item is only applicable to dictionaries. Now let's look at some set operations. I want to show you how to do union of two sets. So A is equal to 1, 2, 3, 4, B is equal to 2, 3, 9, and we want to check what is A union B. To compute A union B, we can use the pipe operator. So A or B should give us the union. So let's execute this. We know union should be 1, 2, 3, 4, and 9. So let's compute and print that. Now A is 1, 2, 3, 4, B is 9, 2, 3, so A union B is 1, 2, 3, 4, 9. We can also use the inbuilt method, which I'm not showing you here, so let's write that. So there is an inbuilt method union that you can use instead of the operator to take union of two sets. So let's look at what happens when we call the union method instead. Now notice again A union B after this call is 1, 2, 3, 4, 9. So either you can use the operator or you can use the inbuilt method union to take union of two sets. Similarly, to compute the intersection of two sets, you can use the inbuilt method intersection, or you can use the operator AND. So A and B is the same as A intersection B. So when I call A intersection B, compute A intersection B, we know that the intersection of A and B is 2, 3. So A intersection B is also equal to 2, 3. Now we can use an inbuilt method intersection underscore update to update our set. So here, notice I'm calling intersection underscore update using the object B. B was initially 9, 2, 3. After executing this line, B should be equal to 2, 3, which is the intersection. So the intersection underscore update simply updates the object that is used to call this function, and the value that is updated with is the intersection. So now B is equal to 2, 3 instead of 9, 2, 3. We can also do set difference using A minus B. So again, A is 1, 2, 3, 4, B is 2, 3, 9. A minus B is all the elements that are part of A but not of B, not part of B. So the elements that are part of A and that are not part of B is 1 and 4. So A minus B should be equal to 1, 4. Okay. Similarly, B minus A is all the elements that are part of B but not part of A, which is 9. So B minus A should be 9. You can also use the inbuilt method difference. So A dot difference B will simply compute A minus B. B dot difference A will simply compute B minus A. So there are multiple ways of doing set operations. You can either use inbuilt methods or you can use the operators. So this concludes the topic on sets. Sets and dictionaries have a common syntax. You can use the curly braces to create sets. You can also use curly braces to create dictionaries. If the items are key value pairs, Python creates a dictionary. If the items are simply values, or Python creates a set. Sets are an unordered collection of items with no duplicates. And sets are useful when we want to do some mathematical operations like union, intersection, or a difference. We should use sets instead of other data structures. So this concludes the topic on data structures. Next time we will see some practical examples of using these data structures and all the concepts that we've learned so far to create a practical program. Thank you.